Hi guys, if you guys haven't figured out by now, I'm not in class today. Unfortunately, I had a little bit of a family situation and I will not be in class the rest of the week. I will be back on Monday though to continue the chapter, but until then, let's try our best to do what we can virtually. Now, this chapter is extremely simple and streamlined, which is why I picked it to go this week while I'm not there. Please try to follow it as much as you can. I guarantee you that with a little bit of work between all of you guys, you can definitely figure it out. So let's start with what we know. We've already studied momentum. We know that momentum has different forms of conservation. We talked about its relationship to kinetic energy and everything in between. So now let's talk about momentum with impulse. Now, when we talk about momentum, we talk about momentum as it's moving, right? So we know up to now that momentum has been P equals mv. That means that it's mass times the velocity. Velocity being change in distance over time. So we know a little bit of the couple equations that go along with it. The best thing that I want you guys to remember is that it is a vector quantity. It does have a direction. Because of this, we can use it when we're looking at kinetic energies. We can use it when we're looking at different types of collisions, which is what this chapter is all about. So we move. As we look at impulse, impulse is the force in the time of which that force acts. So think of impulse in your everyday life as like how quick you decide to do something. Well, impulse in physics is how fast a force takes to act. So I look at the force and I look at my time, and that's the way that I get my impulse. So impulse equals force times time. Now, how are impulse and momentum related? Well, impulse and momentum has a theory. And the theory states that when the net force is applied over a certain amount of time, that force will cause some sort of change in the momentum. This leads us to the equation. That impulse, which is force times time, so that's this piece right here, impulse equals momentum, which equals my change in momentum. Now, because impulse equals a change in momentum, I can now use these formulas for everything that we're going to use in this chapter. So let's think of the difference in between what impulse and momentum means. So momentum is my movement, right? So it's the amount of movement that I'm doing. It's my mass times velocity. Where impulse is the amount of force that's going to be done over a change in time. So we're looking at two different aspects of the same scenario. So here's an example of a scenario. If you notice, in A, the amount of time that the egg has to fall, or the amount of time that the egg has to stop, is very short. It's hitting a plate. There's no movement in the plate. Thus, the amount of force on the object is going to be extremely high. Whereas so on B, the amount of time that the egg has to stop is higher, right? The egg can hit the pillow and then keep going down and bounce back up. That means that the amount of force on the egg is going to be less. Let me give you another example on how to do this. Let's think of two trucks that are coming to a stop. So you're driving down the highway and you're a truck and you're going 60 miles an hour, whatever it is that you're going. And you realize that your brakes have stopped. What would make more sense? For you to run into a brick wall, as lovely as my brick wall is, or for the same truck at the same speed with the same exact mass to fall into a stack of hay? Which one would make more sense? I hope you guys are picking the stack of hay. Reason being that the stack of hay, from the moment you impact it to the moment you stop, will actually give you more time. You have more time to stop because the hay gives you some give. Here, you have no time. Once you stop, that's it. Once you hit it, your time is zero. Because your time is low, your force will be very high. But here, your time is higher, so your force will be on the lower end. It's the same reason for somebody's jumping off a building. If you're on a building and there's firefighters down there, these are two guys trying to save the building's on fire. Let's pretend. And there's two firefighters, and one's holding the trampoline, and one's holding a piece of cement. Which one would you want to jump into? I hope you guys picked the trampoline. When you jump down, the trampoline has some give. That extra movement gives you extra time, which means that your force is lower. Same reason with how cats jump off a building. When cats jump off a building, when they go to hit the floor, they actually, if you look at the slow motion, they move their body in a way. This is my cat. They move their motion in a way that their legs actually hit first. And what happens is their legs hit first, then their knee joints, then their back, and then their back legs. This extra time allows for the force on the cat to actually be lower because the time has raised. Okay, now that we understand how that works, we can now put it into equations. So go ahead and try 6a, maybe 6b. Look at the formulas that I have or the videos that I have up on Edline. They go by section, so just go to 6a and look at how I did that problem and then go try those problems. Then go to 6b and check out how I did that problem and go by those problems. Also make sure that you do the section reviews in the chapter and the section review worksheets. The worksheets themselves I will be collecting on Monday. Make sure they're done for all three. They're on Edline. I will see you guys for section 2.